guys, happy Sunday. I got an email requesting that I work through section 1.1's example 11. So I'm going to go ahead and do that for you guys. I think where it's easy to get hung up is tiny mathematical mistakes when working with square roots. So I'm going to go through this problem. So let S be the set with elements 0, 1, -1, 1/2 times 1 plus the square root of 5, 1/2 minus the square root of 5, and the square root of 1/2 times 3 minus square root of 5. And we're going to define f as a function that maps onto itself, right? So here's our domain and here's our target. And we want to construct the graphs of f squared, and f to the f3. Remember, we really only need to calculate f1, draw the graph, and we can use the graphs to determine what the values would be for f2 and f3. So let's start. If I have f of 0, that means I'm substituting 0 into, oh, I forgot to tell you what the function is. Okay, let's let f of x is the function x squared minus 1. It does say this in your text, but I'm sorry I didn't include it in the PowerPoint. So then f of 0 would be 0 squared minus 1, which is -1. F of 1 would be 1 squared minus 1, which is 1 minus 1, so 0. F of -1 is -1 squared minus 1, which is 1 minus 1, which is also 0. Big shock there. And then it gets a little more complicated because we have to work with these square roots, and they aren't even simplified right. They have a factor of 1/2 pulled out. It's really strange. So f of 1/2 of 1 plus the square root of 5 equals 1/2 times 1 plus the square root of 5 squared minus 1. So the first thing I want to do in order to make my life simpler is I'm going to distribute that 1/2. So that means I have 1/2 times 1, which is 1/2, plus 1/2 times the square root of 5. And unfortunately, that's as nice as we can make 1/2 times the square root of 5 look. Remember, we are also squaring this. So I'm going to take 1/2 plus 1/2 square root of 5 times itself. And I'm going to have to use my foiling rules. Don't forget we've got a -1 out here. I just want to make sure we simplify these two multiplied together first. So remember, we have to FOIL. FOIL stands for first, outer, inner, last. So I'm going to take 1/2 times 1/2. That's going to give me a 4th. I'm going to take 1/2 times 1/2 square root of 5. That gives me a 4th square root of 5. I'm going to take 1/2 square root of 5 times 1/2. That's another 1/4 square root of 5. And then I'm going to take 1/2 square root of 5 times 1/2 square root of 5. That's going to give me 1/4 times 5, because the square root of 5 times the square root of 5 is 5. And I've got this -1 out here. So the first thing I'm going to do is combine like terms. Oh, I made a tiny mistake, sorry. So the square root of 5 times the square root of 5 is 5. So I have 1/4 times 5, and I think I said that, but I wrote it incorrectly. So now I have 1/4 plus 1/4 square root of 5, 1/4 square root of 5. That's going to give me a 1/2, right? 2/4 make a 1/2. And then I have 1/4 times 5. That's 5/4 minus 1. So I've got 6/4 minus 1 plus 1/2 square root of 5. Well, I can write 1 as a fraction. That's 4/4. So that would leave me with 2/4 plus 1/2 square root of 5. Well, that's really 1/2 plus 1/2 square root of 5, which is the same thing we found when we distributed that 1/2. So remember, when we aren't distributing, if we want to undo distribution, we're going to pull out a factor of 1/2. So that gives me 1/2 times 1 plus the square root of 5. Okay, we have 2 more elements in our set left. So let's take a look at 1/2 minus 1/2 times 1 minus the square root of 5. We're going to do that on another page. So if I have f of 1/2 times 1 minus the square root of 5, that's going to be 1/2 times 1 minus the square root of 5 squared minus 1. So I'm going to go ahead and distribute that 1/2. And then I need to remember to take this times itself. So we're going to have to use our FOIL method for multiplying binomials. Even though this isn't technically a binomial, I can't add rational numbers and irrational numbers. So we're going to have to FOIL. 1/2 times 1/2, that gives me 1/4. 1/2 times negative 1/2 square root of 5 is negative 1/4 square root of 5. Negative 1/2 square root of 5 times 1/2 is negative 1/4 square root of 5. And when I multiply my two radicals together, I'm going to get a positive 1/4 times 5. And I've got my minus 1 out here. So I have 1/4 minus 1/2 square root of 5, because 2/4 gives me a half, plus 5/4 minus 1. So again, I'm going to get 6/4 minus 1 minus 1/2 square root of 5. That gives me 2/4 minus 1/2 square root of 5. So I have 1/2 minus 1/2 square root of 5. And I could pull out a factor of 1/2, and I get back to the element that I started with. Last, but certainly not least, honestly, it's a little bit simpler. I have f of 1/2, the square root of 1/2 times 3 minus the square root of 5. And I don't know how long it took Dr. Snavely, our book's really cool author, to come up with this set, but I do have to say it's pretty creative. So I'm going to take the square root of 1/2 times 3 minus square root of 5 squared minus 1. Now square roots cancel squares, so that means I just have 1/2 times 3 minus the square root of 5 minus 1. Let's go ahead and distribute this 1/2. So I have 3/2 minus 1/2 square root of 5 minus 1. Well, 3/2 minus 1, I could write 1 as a fraction, 2/2, minus 1/2 square root of 5. I have 1/2 minus 1/2 square root of 5. If I pull out a factor of 1/2, I get back to one of the elements in our set. Okay, so now I've taken f, I've applied our function to every single element in our set. Okay, I need to draw a map. So this is where we're going to draw our map. I'm going to flip back and forth so that we can see where all of our elements go to. So let's look at what we calculated first. First, I found that 0 goes to -1, 1 goes to 0, and -1 goes to 0. So let's draw that on our map. So I found that 0 goes to -1, -1 goes to 0, and +1 goes to 0 as well. So that's the map of the first 3 elements of our set. We have 3 left. I then found that 1/2 times 1 plus the square root of 5 maps to itself. So let's go ahead and write that in our drawing. I have 1/2 times 1 plus the square root of 5, and it maps to itself. We draw that like a little loop. I also found that 1/2 minus the square root of 5 maps to itself. Maps to itself. And then last but not least, I found that the square root of 1/2 times 3 minus the square root of 5 maps to 1/2 times 1 minus the square root of 5. So let's include that on our graph. It maps to this. So I don't want to have to do a whole lot more math calculations to figure out F2. I can figure this out from looking at my graph. So let's follow what I'm doing in green. So I want to know F2 of 0. Well, F1 of 0 went to -1. So if I apply my function again following this graph, I should get back to 0. Let's do this for every element in our set. If I have F2 of -1, -1 maps to 0, well then 0 maps back to -1. So -1 is also going to map to itself. F2 of 1 would mean 1 first when I applied F once maps to 0, but now that I'm doing it again, it's going to go to -1. We can do the same thing with our more complicated looking elements. Okay, so if I apply F1 once, it maps to itself. If I apply it again, this element still maps to itself. So that's not super exciting. Let's take a look at 1/2 times 1 minus the square root of 5. Well, this element mapped to itself, so it's going to continue to map to itself. Sorry, I was writing these elements a little bit sloppily. It's kind of a mouthful to say these out loud, to be completely honest. So now I have F2 of the square root of 1/2 times 3 minus the square root of 5. If I apply this element, our function to this element twice, first, it would go to 1/2 times 1 minus the square root of 5. But then if I apply it again, it will still go to 1/2 times 1 minus the square root of 5. So let's go ahead and draw our map of F2. I'm going to switch to blue. I have that 0 goes to 0. -1 maps to itself. And that 1 maps to -1. I have that 1/2 times 1 plus the square root of 5 maps to itself. I have that 1/2 times 1 minus the square root of 5 also maps to itself, and that the square root of 1/2 times 3 minus the square root of 5 maps to this as well. Okay? So that would be our graph for F2. For F3, we aren't going to look at where F2 maps to. We want to go back to our original graph of F to apply it 3 times. If I was to follow the path of F2 twice, that would actually give me F to the 4th. So we don't want to do that. Okay. So I'm going to go ahead and erase F2. So if you aren't caught up at this point, you want to maybe go ahead and pause, because I need this map in order to show you guys effectively how to calculate F3. So let's take a look at F3. We're going to take a look at F3. Sorry, this should be like up here. It's early, y'all. It's early. Okay, so we're going to take a look at this, and we're going to use orange so we can see where our elements map to. Okay, so I have that 0 goes to 1. That's our first application. Then -1 goes to 0, and then 0 will go back to -1 if I apply this 3 times. So F3 of 0 is -1. F of -1, I'm going to do the same thing. So -1 originally mapped to 0. Then it mapped back to -1. Now I apply it a 3rd time, so it's going to go to 0. F3 of +1 is where it gets a little more interesting, because 1 goes to 0, then 0 goes to -1, and then -1 goes back to 0. So F of 1 is also 0. F of 3 of 1/2 times 1 plus the square root of 5. This is a little more interesting. Okay, I'm being completely sarcastic because it just goes to itself 3 times. It's always going to map to itself. F3 of 1/2 times 1 minus the square root of 5 does the same thing. It maps to itself 3 times, right? And then F3 of the square root of 1/2 times 3 minus the square root of 5. We need to apply this 3 times. So the first time it maps to 1/2 times 1 minus the square root of 5. Then we maps to itself again, and it maps to itself again. So we still get 1/2 times 1 minus the square root of 5. So let's draw this beautiful picture. I have that 0 goes to -1, -1 goes to 0, and 1 goes to 0. I have that 1/2 times 1 plus the square root of 5 maps to itself. 1/2 times 1 minus the square root of 5 maps to itself. And the square root of 3 minus 5 square root, oh my gosh, what am I making up? 1/2 times 3 minus the square root of 5 maps to 1/2 times 1 minus the square root of 5. So I hope that helped explain why you got the answer that's displayed in figure 1.9 in the text. I think they're really good about answering most of the examples. If you guys ever have any other questions you'd like me to work through, I'm here for you guys. I understand a lot of you have been trying to type up your homework in Word because Amazon's not as available as it used to be. I'm happy to check it and make sure it looks okay. And I'm happy to take your homework in whatever form, be it paper or submitted. Just make sure you reach out to me if you have any questions or concerns. I hope you guys have a wonderful day enjoying this fall weather. I'll talk to you soon. Bye.